It says a population of ants is counted on the 8th and 10th days in an experiment. Their population grows exponentially daily, and you need to find out how many ants there were at the start of the experiment and the equation that models their population from the start. So they give us that there were 480 million ants on the 8th day and approximately 5,680,000,000 ants on the 10th day. So we're going to say B is the rate at which the population grows. So B squared will equal how many ants there were on the 10th day over how many ants there were on the 8th day. So like that. And so that equals approximately 11.83 repeating, or 71 over 6. And so that's what B squared equals, so we need to take the square root of that. So therefore B equals root 71 over 6, which is approximately 3.43996. So that's how much the population grows by each day. And so the exponential equation for a general exponential equation is y equals ab to the x. And so y is on the 8th day, so 480,000 equals a times the rate at which it grows to the 8th, because it was on the 8th day. And so just to get a by itself, and so A turns out to be approximately 24480.08064. So this is when the population equals 0. When x equals 0, the population is 24,480 ants, and x is the number of days. So y equals 24480.08064 times 3.4399624 to the x. Okay, so this question says the intersection of the planes 4x minus 3y plus z equals 1 and 3x plus 2y minus 4z equals 3 is a line, one of whose points is 1/6, 3/5. Write the parametric equation for this line. So we're going to take vector a and b, and that's just going to consist of the coefficients of the plane. So a is going to be 4, -3, 1, and b will be 3, 2, -4. And these are vectors. And so then we're going to take the cross product of the vectors, so a times b equals -3 times -4 minus 1 times 2. That's going to be x, comma 1 times 3 minus 4 times -4, which will be y, and 4 times 2 minus -3 times 3, which will be z. So that simplifies down to 12 minus 2, 3 plus 16, and 8 plus 9. And then you get 10, 19, 17. So that's the cross product. I found this point, which is the point of the intersection on the line. And so just to show you how I got that, so we're going to say x equals 1, and we're going to plug that into both planes. So you get 4 minus 3y plus z equals 1. So -3y plus z equals -3. And 3 plus 2y minus 4z equals 3. So 2y minus 4z equals 0. And we're going to just get z alone. So you get z equals -3 plus 3y. And we're going to plug that in for the z here. So 2y minus 4 times -3 plus 3y equals 0. So 2y plus 12 minus 12y equals 0. So -10y plus 12 equals 0. So -10y equals -12. So y equals 12 over 10, which simplifies down to 6 over 5. So we know x equals 1 and y equals 6 over 5, and now we're just going to plug that back in to this z equation here. So z equals -3 plus 3 times 6 over 5. So z equals -3 plus 18/5. So z equals 3 over 5. So now that we know that that's the point, we can get the equation. So it's y equals 1 comma 6 over 5 comma 3 over 5 plus t times 10, 19, 17. And t equals all real numbers. So that's your equation. Next question is find the equation of the ellipse with directrix x equals 20 and foci plus or minus 5, comma 0. So the eccentricity is c over a, and we know what c is, it's 5. They give you this foci. So you can say 5 over a, and you can set that equal to a minus 5 over 20 minus a, and you get the 20 from the directrix. So just cross multiply and you get 100 minus 5a equals a squared minus 5a. So the 5a's cross out. You get 100 equals a squared. So therefore a equals plus or minus 10. Now you want to find b. You know the equation a squared equals c squared plus b squared. So 10 squared equals 5 squared plus b squared. 100 equals 25 plus b squared, so 75 equals b squared, and therefore b equals plus or minus the square root of 75. And then they want the equation, so it's x squared over a squared plus y squared over b squared equals 1. So it's x squared over 100 plus y squared over 75 equals 1.